design. Database design is nothing but how you are placing your records in a specific format. Okay, like we have different formats now to store data. Similarly, when you want to store some records in terms of database, so what design you are considering? Okay, the database systems are designed to manage the large bodies of information. What does database comprise of? Database comprises of a huge amount of information. Okay, these large bodies or this large amount of information do not exist in isolation. Isolation means they are not individual. The data stored in database is in a combined form. Multiple types of data you can store into your database. Like for example, when we discussed the previous example about the instructor, so in a database we had more than one table, or we can form more than one table in a database. Okay, and different table may contain different types of information. So no specific information is kept isolated, is kept unaware of the other table. They are part of the operation of some enterprise whose end product may be information from the database, or it may be some device or service for which the database will play a supporting role. Supporting role means somewhere you will be using the reference of the table. So just now we saw the example. So select what? Select instructor id. Instructor id from where? From the instructor table. So what you are giving? You are giving the reference that you need to select this attribute from the reference we are providing, that from this table whoever is comprising of this reference id, so I want the data of that particular person. So here you give the reference or the supporting role. The database design, the point which we are dealing with. So the database design, it involves the design of the database schema. Schema is nothing but the format. Okay, the representation of the data. The design of a complete database application environment that meets the needs of the enterprise being modeled requires attention to a broader set of issues. When you are designing a database, okay, and that database will comprise of tremendous huge information of certain enterprise, so in that case obviously there will be much larger issues. So how to tackle those issues and how to handle those issues and then create a huge database, so those things are considered under database design. A high level, we have different levels of data models or database designs. Okay, like we have different levels of programming languages now, right? So similarly we have different levels of database designs. So the first is the high level data model. This particular level will provide the database designer, the person who is going to design a database. Suppose you can be a database designer if you are creating multiple tables. Okay, if you are making a database, in that database you are creating a multiple tables, so obviously you will be termed as database designer. So high level data model will be providing the database designer with a conceptual framework in which to specify the data requirements of the database users and how that database will be structured to fulfill those requirements. Suppose when we need to write a program, what we do? We usually write an algorithm and then we prepare a flow chart and then we write the code. Right? This is the format when we write a, suppose a basic program in C language. So how we studied that? First we used to write algorithm, then flowchart, then we used to go to program. So similarly here also those steps will be considered. Steps here will be considered was what type of data was is expected to be stored in the database, how we can store that data into the database, in what format we can store the data into the database. Suppose in a company you can give reference IDs or you can give employer ID. So are we giving employer ID or are we giving reference ID? So those things will be specified in this level. The initial phase of the database design then is to characterize fully the data needs of the prospective database users. Why do we create an application? Suppose we are software developers, so why do we create a software? We create a software so that users can use it. But when we create a software, when we create an application, what we have to keep in mind that will it meet the user's demands? What is the demand of the user? We need to prepare a software according to the user needs. Yes, so similarly the database, if you are preparing a database for specific purpose, for specific company, so you need to keep it in mind that whatever database I will be creating, it will be useful. I am mentioning the data, the whole data, the complete data which I am getting from the company. Suppose every employer's information, then which employer is working under which head. For different departments, different employees will be there. So which employee is working in which department, who is the head of that particular department. Okay, so all those data should be present in your database, then only your database will be useful to the user. The database designer needs to interact extensively with the domain experts and users to carry out this task. Unless and until you don't have that, the user demands, you don't know the vision of the user, what a user expects from a software, and then whatever you will prepare, it will be useless. So what you need to do, you need to first understand the vision of the user, that what a user is expecting from this software to be implemented, and then you should again use prepare a software accordingly. The outcome of this phase is a specification of the user requirements. The next step, the designer will choose a data model, and then by applying the concepts of the chosen data model, translates these requirements into a conceptual schema of the database. First, a designer is interacting with the user. What type of data you want to be stored in this database, what are your expectations of data to be stored in this database. Okay, that will be the first step. After that, what the database designer will be doing, it is going to select a particular data model. Okay, why data model? Because if you want to create a database, so you should have a specific format. Unless and until you are not having a specific format, randomly you cannot create any database. For specific reasons, you should have a specific format in which you are storing the data, and then you are combining that data model and user requirements, and you are calling it as a conceptual schema of the database. Okay, that will be a schematic representation. Before we build a house, what do? We create a 3D design. Okay, or we create a blueprint, you can say. Why do we create a blueprint? We cannot directly go and construct house. First we need to create a blueprint, we need to take the permission from the government, and then only you can construct the home. So similarly here also you need to ask the specifications, then you are applying those specifications to create a database. So the schematic representation, the format, the structure developed at this conceptual design phase provides a detailed overview of the enterprise. The designer reviews the schema. Now again the designer will review. What the designer will be reviewing? The structure, the format which a designer is using to create the database. So designer is reviewing that schema to confirm that all the data requirements, whatever information a client wants, are those information being specified into this database if I am using this particular structure or format. Okay, the designer can also examine the design to remove any redundant features. If like if we write code, so if a person is expecting xyz thing, and as a programmer, what we know that if we are not writing y, so then also a customer will get whatever customer expectation is. So what we do, we remove y. So similarly here also some parameters can be removed if a designer knows that if this is not mentioned in the database, then also it will meet the needs of the consumer. Okay, The focus at this point is on describing the data and their relationships rather than on specifying the physical storage details. How you are describing, like what type of data it is. Okay, describing the data means what type of data, for what purpose it is. You are mentioning that data, or you are storing that data into the database, all those details, and how the data is related to one another, whatever the tables are there, whatever the detail is stored in those tables, so how those data records are related to one another. So it is of utmost importance at this high level. Okay. In terms of the relational model, the conceptual design process involves decisions on what attributes we want to capture in the database and how to group these attributes to form the various tables. The what part is basically a business decision and thus it is not discussed further, but the how part is mainly a computer science problem. You have two ways to tackle this what and how problem. The first one you can use is the entity relationship model, and the other is to employ a set of algorithms which is collectively known as normalization. What this normalization process will do, it is going to take some inputs, the inputs this which will be comprising of the set of all attributes, and then it is going to create a set of tables. Two methods you have for what purpose? To store data into the database. Okay, you can store data into the database using the entity relationship model, and the second method will be the normalization technique. A fully developed conceptual schema indicates the functional requirements of the enterprise. In a specification of the functional requirements, whatever requirements will be there, so are those requirements functional, are those requirements being implemented or can be implemented, and you are specifying a certain technique over those requirements. So in a specification of functional requirements, users describe the kinds of operations that will be performed on the data. Kinds of operations, just now we saw four operations now, right, in DML: insert, then access the information, then modify, then delete. So what type of operation will be performed over the data, you can describe that also. Examples of operations include the modifying or updating the data, then searching for, that is accessing the data, and retrieving, and then deleting the data. At this stage of conceptual design, the designer can review the schema to ensure it meets the functional requirements. Then the process of moving from an abstract data model to the implementation of the database proceeds in two final design phases. We have seen the term abstract. What do you mean by abstract, and how does this abstract data model works? Now moving from a low level to a higher level. Okay, moving from a crude level to a much more detailed level. So you have two phases. One is the logical phase and the other one is the physical design phase. See, we have three phases. One will be the conceptual design, that will be the first step. Then after that we have logical design phase, and then after that we have physical design phase. So in logical design phase, what is happening? Up till now we have seen that how the conceptual design phase works and what is the importance, what is the significance of conceptual design phase. Now we will see the logical design phase. In this, what is happening, the designer maps the high level conceptual schema onto the implementation data model of the database system that will be used. Program is being written, now you are creating an application using that program so that it can be used by the user. Okay, we write code, but unless and until we are not giving a front end, so that code will be useless. So code is written, now you are providing front end. So logical design phase is the same. Okay, you provide an interface. The designer, that the final step, that is the physical design phase. In this, what is happening, the designer uses the resulting system specific database schema in the subsequent physical design phase, in which the physical features of the database will be specified, the data will be visible. Okay, here we have example that database design for a university organization.